capable of doing that, but it's going to take a part of that antigen and present it on its own membrane. And in this particular case, it's going to present that. So let's assume that this has been taken in, it's been destroyed, and we're going to stick parts of this antigen now out through the membrane, and it's going to show this structure, this destroyed antigen. It's going to present it as the term we use to this T cell up here. And this T cell, in turn, which is still undifferentiated, meaning it hasn't decided what it wants to be when it grows up, it is sensitized by the presence of that destroyed antigen that has been shown to it by this macrophage, and with the presence of interleukin-1, which also stimulates these cells to react to this, these T cells start to mature and differentiate. And look what they do. And this is not all of them. I'm not going to ask you to know all of these. And we'll just kind of simplify this. We have amplifier Ts, memory Ts, helper Ts, suppressor Ts, killer Ts, delayed sensitivity, hypersensitivity Ts. But the ones we're most concerned about at this point are these guys right here. Because these killer Ts are the ones which have now been shown what the antigen looks like, and they are now on the lookout. So they start to reproduce rapidly, producing more and more killer Ts that have that memory in them. You know what this stuff looks like, and in turn, they get destroyed by a whole variety of ways, because these are basically phagocytic. That's the most common way they're going to destroy the antigen. In turn, what we have are helper Ts, and who are they helping? Well, they're going to help these killer Ts. Even though these have been stimulated to reproduce and produce lots of these that know what this antigen looks like, it's the helper T, which produces another type of cytokine, another interleukin, which causes more proliferation. It helps to increase the number of killer Ts. And what we'd like to have happen is that we rid our body of those antigens until we reach a point where we're going to say to this killer T, back off. Back off now. You've done the job. You need to slow down. And who takes care of that but suppressor T, secreting again a type of interleukin which says to those cells, okay, metabolically, let's back off. You did a great job. The war is over. Let's stop this process. And we also have memory Ts. You can guess what the function is. If that same antigen shows up again, do we need to go through the presentation thing and all of that? No. We don't need to go through all of this stuff to come down here again, because the memory T is going to go, whoops, it's back again, and what is it going to do? It's going to start to differentiate into helpers and suppressors and killers and activate killers and get the whole thing going again. So the response rate to the antigen is reduced significantly. How many different killer Ts do we have in our body? Don't know. How many antigens have you been exposed to since you were born? Billions. Billions of bacteria and fungi and protozoans and toxins, all that stuff. So theoretically, you've got all of these memory cells kind of hanging out. What about these guys? Anybody get poison ivy? Never. Okay, I don't want to see it. You've got a sensitivity. Did you always have a sensitivity to poison ivy?
No, I've never been.
Okay, out of the blue? Got it right now, though?
Yeah.
Okay, I'm not sure you got it. Why all of a sudden?
I went.
Okay, but do you think you were exposed to poison ivy before this time?
Oh, yeah.
Okay, why didn't you get it before? What has happened now is that for some reason, which we can't fully explain, the oils that are produced by that particular plant are stimulating these specific T cells, and what do? They create a hypersensitivity. So instead of saying, let's establish an infection or an inflammation and let's kill these things off and do so, it overreacts to the presence of the antigen. So somehow your delayed hypersensitivity T's now have been stimulated, and your body's going to show that kind of a reaction on the skin. So do we want these guys to be there then? Well, it's a warning to you not to go back and fiddle and poison ivy, isn't it? So you got this kind of sensitivity to that, and now it's kind of a way of saying, okay, what caused that, and now what do I have to do to keep from getting this again? Run with it.
Is that why sometimes you get those allergic things that you've never been allergic to?
Exactly. And that's why sometimes you'll end up with sensitivities that you've never had before, and all of a sudden you develop a hives, rash, whatever it happens to be, to a substance that you, strawberries. Some people can eat strawberries their whole life, and they sit down one time and have strawberry shortcake, and they swell up like a prune, a swollen prune that's been sitting in hot water. You know. Okay, so that's the T cell business. What happens with the B cell drive? We had this fluid adjustment. It's okay. Anybody else have to take a leak? Should we break real quick for a minute, or should we just finish this? Finish it, okay. Okay. So here we go again. Slightly different scenario, but there's our macrophage. Same scenario, really, when you think about it. And what has it done? It's found an antigen, it's engulfed the antigen, it's phagocytized it, it's killed it, it's destroyed it, it puts part of this antigen, presents it on its membrane. In this case, we're going to show it not to T cells, but to B cells. Could the same macrophage show to T and to B? And the answer is yes. No, you aren't? Was it? Okay. Just pass it up, so what happens in this particular case? There's our T cell guy, he's doing his thing over there and all of that. But now we've got B cell, but look who gets involved here. What's that TH? Helper T. So here comes the helper T. He's not just helping T cells, but he's also helping, or she, B cells. And what is this B cell going to do? This B cell, and this gets complex, but we'll keep this as simple as we can. The B cell responds by dividing very rapidly and forming what are called plasma cells. Remember on the sheet, plasma cells was under B cells? And those plasma cells, in turn, are going to sit out there and they're going to say, okay, I'm going to wait for the next antigen to come along. I'm not going to respond to this. So the plasma cells go out. But then, in turn, we've got antibody-producing B cells. So now we've got a set of cells whose function it is, and you see the plasma cells coming down here and cloning off, and memory, we're going to get some memory ones out of all of this stuff. And the plasma cells are eventually going to differentiate into antibodies secreting cells. So we've got plasma cells which sit over here beside the one, and their job is to kind of go up in this group, and we have other plasma cells which are going to come over here and differentiate into antibody producing and secreting cells. They're cloned, which means that they are all reproducing rapidly and all have the capability of producing this stuff. Now this is just one kind of antibody. What is antibody? Let's look at it on here. This is the one I was looking at before. So Here's our B cell. It's been activated because, actually,